Welcome, ladies and gentlemen, to section 8.4, which is solving logarithmic functions. As you can guess, today's objective is to solve logarithmic functions. So we're going to have equations that involve logs, and we're going to solve for a variable, generally x. Today's video is no calculator, so you shouldn't be using a calculator. So we're just going to jump right in by solving the following logs. So looking at examples 1 through 4, we have 4 equations that involve logs, and then we have a variable x somewhere, and that x changes. The first thing that I'm going to tell you to do is to switch to exponential form. We're just learning logs. We're not really comfortable with log form yet, so we're going to switch to exponential and see where we can go from there. Hopefully you remember that 6 is the base, x is the exponent, so this becomes 6 to the x equals 1 over 36 is the argument. It's what goes by itself. Now this should look familiar. You have solved equations like this before. Remember that you need to get both sides in terms of the same base. So 6 to the x, I'm just going to keep 6 to the x. 36 is 6 squared, so 1 over 36 is 6 to the negative second. Now I have the same bases, 6 and 6, so my exponents are equal. X equals negative 2. That's it. That's example 1. So this shouldn't be too difficult. It's not really anything new. All you're doing is converting to exponential form and then solving. So let's try example 2. Log base 36 of x equals 3 over 2. So again, we're going to start by putting in exponential form. 36 is our base. 3 over 2 is our exponent. The argument x goes by itself. Okay, now I'm going to notice x is already by itself. So all I have to do is simplify that left side of the equation. I'm going to rewrite that. Right now, it's in exponential form. I'm going to put it in radical form. So this is something that we did last chapter. Remember that the 2 is what goes outside. So it's the square root of 36 to the third power equals x. You should know that the square root of 36 is just 6. So this is 6 to the third equals x. 6 to the third, hopefully you remember, is 216. So in this case, we get x to be 216. Okay, right now what I would like you to do is pause the video and try example 3 on your own, please. Just example 3. Do not go on to example 4. So put it into an exponential form and then solve. Good luck. Okay, let's see how we did. Exponential form should have been x to the power 3 over 2 equals 27. Now, you're going to notice this looks different from the previous 2 examples. This is the only case where x is the base. So x is the one that we're taking a power to. Okay, so now I need to think, how can I get rid of that exponent? Because remember, I'm solving for x, so the issue right now is that power of 3 over 2. To get rid of that, we take everything to the reciprocal power, which would be 2/3. On the left side, those powers cancel. I'm left with x. On the right side, I have 27 to the 2/3 power. So x is 27 to the 2/3 power. So now all I have to do is figure out what 27 to the 2/3 power is. I'm going to rewrite this in radical form. 3 is what goes outside. So it's the cube root of 27, all of that squared. Okay, now, if you don't remember the cube root of 27, remember 27 is 9 times 3, 9 is 3 times 3. 27 is one group of 3's, so the cube root of 27 is just 3. So really, x is 3 squared. So I get x to be 9. Okay, my guess is that that one might have given us some trouble. Maybe we don't remember taking one side to the reciprocal power to get rid of the power. So right now, I would like you to pause and try example 4 on your own, please. It's the exact same setup, but different numbers. Good luck. Okay, let's see how it went. You should have gotten x to be 27. If you didn't, you did something wrong. If you did not get 27, go back, watch example 3 again, and then complete example 4. Examples 3 and 4 should be very similar. If you did get 27, good job. We are now going to move on. Okay, so next we're going to be learning about the property of equality for logs. It says log b of x equals log b of y if and only if x equals y, which you probably could have guessed. So what I want to point out here is we have the same base on both sides. We have log base b, log base b. If you have the same base, then the arguments are equal. So in the example, we have log base 5 of x, log base 5 of 8. So both sides have log base 5, so the arguments are equal. So x equals 8. Now that was a much simpler example than what we're going to be doing in class. What we're going to be doing in class is a little more complicated, but it uses the same idea. So we're going to do examples 5 and 6 together. You all are going to do 7 and 8. Looking at example 5, I have log base 2 of x squared minus 4. I have log base 2 of 3x. Okay, so log base 2, log base 2. My bases are the same, so I can set the arguments equal. I have x squared minus 4 equals 3x. Okay, now, how do I solve this? Well, I have an x squared and I have an x. So the first thing that I'm going to do is get everything over to one side. So I'm going to subtract that 3x. So this becomes x squared, subtract 3x, subtract 4 equals 0. Okay, I now have a quadratic. Few ways to solve a quadratic. I could do the quadratic formula, I could factor, I could do the square root method. Right now, the square root method does not apply, so I'm going to try to factor. I'm looking for two numbers whose product is negative 4, so that multiply to negative 4, and whose sum is negative 3. So multiply to negative 4, add to be negative 3. Well, that's going to be negative 4 and positive 1. So I have x minus 4, x plus 1 equals 0. Setting both equal to 0, I have x minus 4 equals 0, x plus 1 equals 0. So I end up with x equals 4 and negative 1. Now, before I go any further, I need to make sure, do both of these answers work with the equation that I'm given? Well, let's substitute in 4. I'm going to start on the right side. If I substitute in 4, I get log base 2 of 12, which is possible. If I substitute in 1, negative 1, I get log base 2 of negative 3. That does not work. We never take the log of negative numbers or 0. So negative 1 does not work. 4 is the only answer that works. We should substitute into the left side as well. I should have told us that, so let's just do that real quick. If I substitute 4 in, I get log base 2, 4 squared is 16, minus 4 is 12. So I get log base 2 of 12 equals log base 2 of 12. So the right side is what really was the issue, but you should substitute into both sides to make sure they work. Okay, let's try example 6. Again, I have log base 2. Log base 2, log base 2, they're the same. So I'm going to set the arguments equal. I have x squared minus 15 equals 2x. Subtracting 2x, I get x squared minus 2x minus 15 equals 0. Looking for two numbers whose product is negative 15 and whose sum is negative 2. So two numbers that multiply to negative 15 and add to be negative 2. Hopefully you know that that's negative 5 and positive 3. So I have x minus 5, x plus 3. This gives me x equals 5 and negative 3. I need to make sure both work. As you can guess, probably guess, that negative is the one that we're more concerned about. So I'm going to substitute both into the right side. I get log base 2 of 10. When I substitute in 5, that's good. I get log base 2 of negative 6 when I substitute in negative 3. That does not work. We never take the log of a negative number, or 0 for that matter. Negative 3 is not going to work. So far it looks like x equals 5 is a good answer, but I'm going to substitute back into the left equation just to make sure. So in the left side, I get log base 2 of 25 minus 15, which is log base 2 of 10. And my left and right side match, which is good. So my answer is x equals 5. Okay, I would like you to try example 7 on your own, please. Pause the video, try this one right now on your own. Please make sure you check to make sure your answers make sense. Okay, let's see how we did. Bases are the same, so you can set the arguments equal. So you have x squared minus 10 equals 4x. Subtracting 4x, you get x squared minus 4x minus 10 equals 0. Now you should have looked for two numbers that multiply to negative 10 and add to be negative 4. Well, the only numbers that multiply to 10 are 10 and 1, 2 and 5. Neither of those are going to add to be 4. So what did you do next? Did you just quit? Hopefully not. Hopefully you used the quadratic formula. I'm going to guess we might have forgotten this one. This is the one that we learned back in chapter 5. It has the song with it. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, remember a is what's in front of the x squared, b is in front of the x, c is the number by itself. So let's continue substituting. B is negative 4, so the opposite of that is going to be positive 4. So I get positive 4 plus or minus square root of 4 squared minus 4 times 1 times negative 10 all over 2a, 2 times 1. So this becomes 4 plus or minus the square root. 4 squared is 16. Negative 4 times 1 is negative 4 times negative 10 is positive 40 all over 2. So this becomes 4 plus or minus the square root of 54 all over 2. I have to simplify that square root of 54. 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2, so I have a pair of 3's. So this becomes 4 plus or minus 3 root 6 all over 2. That 3 on the outside comes from the pair. The 6 underneath the root are from this 3 and this 2 that don't have a partner. I cannot simplify this anymore. There's nothing that goes into both 4, 3, and 2 with the exception of 1. Now remember that this has two answers, 4 plus 3 root 6 over 2 and 4 minus 3 root 6 over 2. Now 4 minus 3 root 6 over 2 is going to be a negative. So my only answer is 4 add 3 root 6 over 2. If you got that, wonderful job. That's awesome. If you didn't, that's okay. I know that quadratic formula was a little bit of a throwback, so you might not have remembered that. Right now, I would like you to pause the video and try example number 8 on your own, please. Just as a hint, you're either going to have to split the middle or use the quadratic formula. Good luck. Okay, let's see how we did. You should have noticed your bases are the same, so you can set your arguments equal. You should have gotten 4x squared minus 3 equals 11x. Subtracting 11x, you get 4x squared minus 11x minus 3 equals 0. Now, I told you, you can split the middle or do quadratic formula. Either way, the answer you should have gotten is x equals 3. So, if you did not get that, you need to go back and figure out what you did wrong. Remember, you get two answers. One of them is a negative, though. So that negative answer does not make sense when you substitute back into your equation. X equals 3 is the only answer that makes sense. If you did not get x equals 3, you need to go back and find your mistake. I already gave you the quadratic formula over here. So no excuses when you come to class tomorrow. You better make sure you have examples 4 and 8 completed. I gave you answers, but you need to show the work. If you have any questions, please bring them to class tomorrow. See you tomorrow.